Hello friends, welcome. In this video, we'll be looking at one of the problem from GATE CS 2018 that was asked from operating system subject from the deadlocks topic. The questions that are related to this topic are typically straightforward and they are pretty easy to score. So let us look at the question. The below question was asked as a numerical answer type question for 1 mark. The question is as follows. So the question is, consider a system with 3 processes and that share 4 instances of the same resource type. Each process can request a maximum of k instances. The resource instances can be requested and released only one at a time. So we have to find what is the largest value of this k such that it will always avoid the deadlock. We can use this simple formula and arrive at the result within seconds. But let us understand what is the intention behind solving this problem and how we can easily arrive at this result within seconds on the fly. So let us take a hypothetical example, hypothetical scenario. Let us assume that we are given 3 processes, p is equals to 3, p1, p2, p3, and let there be r which is equals to 6, which is the number of instances of a particular resource that is available in the system. Also let k is equals to 3 be the maximum number of instances of the resource each process requests or needs. So each process needs or requests maximum of 3 resource instances. So let us investigate 3 different time scenarios to understand what is the situation that is given in the question. Let us investigate at time instance t1. p1, p2 and p3, all 3 processes requests 1 unit of resource r. Since there were 6 units of resources at time instance t1, the request can be successfully granted. So each process gets its requested resource. So now after time instance t1, p1, p2 and p3, all 3 have 1 unit of resource r. Now at time instance t2, let's assume that p1 and p3 request for another unit of resource r. Now at time instance t2, there were 3 resources that are still left with the system. So this request can be granted. So p1 and p2 gets another unit of resource r. So now after time instance t2, p1 has 2 units of resource r, p2 has 1 unit of resource r, and p3 has 2 units of resource r. So we are still left with 1 unit of resource r which is unassigned to any process. Now assume that at time instance t3, p2 and p1 again requests for 2 units of 1 unit of resource r. Now even the operating system grants 1 resource to p2, but p1 the request of p1 cannot be granted since no more resources of r are left. So if we carefully observe, after time instance t3, the system will be in deadlock because no more requests can be successfully granted, and also we cannot forcefully preempt a process. So after time instance t3, the system is actually in deadlock. Since there are no more resources which are available and no process can actually complete its execution. So let us investigate this exact time scenario t3 to arrive at the solution or the formula that we will be using. So if we carefully observe this time instance t3, we can see that each process actually holds k-1 resources, where k were the maximum need of each process. So the total number of resource instances that were available to the system where r is which is equals to 3 into 3 minus 1, which was 6. So which we can deduce as p into k-1. Now if we just add 1 more resource to this system, then the deadlock would have been avoided. That is, if we had 7 resources, then whatever may be the scenario, this deadlock would have always been avoided. So we can easily arrive at the formula for minimum number of resources available to always avoid the deadlock. So p into k-1 plus 1 is less than or equals to r. So by investigating time instance t3, we could observe that if p into k-1 resources are granted already, and if we add just 1 more resource, then we can always avoid the deadlock. And if these are the number of resources that are available, then we can always avoid the deadlock. But we have to note that this formula would only work if the system has single type of resource. In the question it was mentioned that there were 4 instances of the same resource type. Then we can use this simple formula. If there are multiple type of resources, then we have to use Banker's solution to check if the system is in deadlock or not. Now let us come to the original question that was asked. We are given R, which is equals to 4 instances of the same resource, and we are given 3 processes, and we have to find the maximum value of k, so where k is the maximum instances of each of resource each process needs. So just by plugging in the values, we can easily understand that k is less than or equals to 2. That is, if each process requires maximum of k resources, then also system will not be in deadlock. So the maximum level of k such that it always avoid the deadlock is 2. So the simple answer to this question is 2. Using if each process requires a maximum of 2 instances of resource, then also the system will always avoid deadlock.